You are listening to episode 3 of the ACT Next Navigator podcast. I'm Adam Burke. We're talking again about a video game. No, not that one. This is our follow-up podcast about the collaborative problem-solving game ACT Next is developing called CPSx. The game was featured in a recent TV news story by KCRG reporter Aaron Scheinblum. He interviewed ACT Next data scientist Dave Edwards.
You start out not really knowing what to do, and the whole point of it is to try to figure out what to do.
There's a crisis in space. Jace and Athena are the two hoping to solve it.
Cut the second wire from the left.
We got it.
It's a problem-solving game students are volunteering to play. They're placed in separate rooms with a headset as their only way to work together.
Okay, did one of the panels flash?
Click and hold the on button for exactly 3 seconds. We kind of struggled a little bit, but after a little bit, it was good.
But it's actually a study that ACT is monitoring.
We're just trying to figure out ways of improving our ability to measure that collaborative problem solving, specifically really in order to help students learn how to collaborate better.
They're tracking everything from communication skills
So go over 1 to the right.
to where someone focuses their eyes.
We'll watch the player's face and see whether or not they're showing signs of frustration or happiness, especially in the face of failure and success.
The front as a video game helps, but educators are hoping this game could make a difference to help students learn.
It's not just Fortnite or some of those other fun games that they play on their free time, but it can also be used to solve real-world problems and prepare them for life after high school.
If they find it fun and it's helpful, then we've really kind of hit the sweet spot of something that they're wanting to do that also helps.
For those students trying to beat the clock, here's some advice.
Just talk a lot. Make sure you know your partner. Yeah, communicate.
In that clip, you also heard Northwest Junior High Principal Elizabeth Bruning and some Northwest Junior High students who played the game. Now let's hear from Saad Khan. He's the AI and Machine Learning Director at ACT Next, and he'll give an overview of the game and talk about the chain of evidence researchers use to measure collaboration.
We want to talk to you about a project that we're super excited about. It's called CPSx. CPS stands for Collaborative Problem Solving. The initiative is about how do we build valid, ecologically valid measures of a very complex skill, collaborative problem solving, and not just in the form of a summative test, but really a formative learning experience as well. And this is a project that's been ongoing for about, I want to say, a year or so, and it's a large team effort within ACT Next. So here are the project people that you see who are, in the thick of it, but there are others who have contributed to this project in one way or the other. We've got Praveen Chopade, who's on the Zoom link today. He couldn't be here, unfortunately, but we'll cover for him. We've got Dave Edwards, who's going to be talking about most of what you'll hear today, and has been leading a lot of the work when it came to our pilot data collection study that you'll hear a lot about today. We have Alejandro Andrade on Zoom as well. He's based out of our Denver office. Scott Pugh, who is local, he's right here. Myself and Brian Maddox, who's our collaborator from University of East Anglia. I'm just going to give you guys a brief overview and then hand it over to Dave to talk about a lot of the details around the pilot data collection study that we just concluded, as well as some of the analytics and the analysis that we've done. There is a broad acknowledgement that we want to go beyond just your traditional cognitive skills assessments or what's necessary perhaps even to be successful in higher education, in the workforce, is beyond skills in math, writing, and science and what have you. Those are really essential, but you need beyond that. And the kinds of skills that are necessary to be successful in the modern workforce include the so-called 21st century competencies, things like communication ability, teamwork, creative thinking, problem solving, and so forth. While we all acknowledge that is the case, we also know that's very hard to actually come up with valid measures or assessments for skills like those. And then, how do we actually remediate those skills is just another question from there on. And part of the reason for that is that it's not just the end goal that matters, that you have a score that you can determine on collaborative problem solving. The challenge really is that the kind of data that we want to be able to use to be able to come up with a measure and provide feedback is inclusive of the thoughts and processes that led to a final goal. To be able to really do that, you want to expand the kind of data that you can capture. So it's going to be beyond just responses to items. It would actually be data that's captured in the wild. So it could be a sample of somebody's communication with each other. So it could be video data, it could be speech data, it could be log files data that are captured on a simulation platform that is designed to elicit skills that we're interested in assessing. It's not as if we don't have access to enough data to be able to measure these validly. Somewhat paradoxically, it's that there's a data deluge. And the challenge is, how do you actually extract meaningful evidence, actionable evidence from that deluge of data? So to that end, a lot of the work that my team, the AI machine learning team at ACT Next does is work on innovations and advances in the state of the art to address that challenge. And one of them is what we call multimodal analytics. The idea with there is that can we combine multi-sensory data? Data could be video, audio, speech, or what have you, and extract from it a multitude of behavioral markers that could then be fused to get to a holistic assessment, a holistic picture of the state of the trainee. So what we know for sure is that it's almost impossible to get to a summative score of a very complex competencies by taking into account just the raw low-level data that you can capture. Is it possible that you capture the complex data that I just talked about, so it could be in the form of video or 3D or speech, and maybe build a regression model that would give you a score on how well you do as far as your communication skills are concerned? Now, we know that's just simply not possible. The data is too complex, too noisy, too interconnected, and so forth. An alternative approach, where I feel is a lot more valid and I think more powerful in addressing this particular challenge, is to create a deep hierarchical inference model. So it's essentially a progressive set of accumulations of evidences on more high level of abstraction as you go from the low level all the way to the top level. What we're trying to do is marry data-driven and theory-driven approaches. So you might actually be able to capture the raw data in a multitude of modalities, but instead of just trying to make a direct connection between the low-level data with the high-level construct, we can break up the high-level construct into intermediate mid-level representations. So in this case, we're talking about collaborative problem solving. Perhaps it's a combination of things like knowledge assimilation, positive communication. How does knowledge assimilation actually look in the real world? So we work with SMEs to break that further apart and say perhaps knowledge assimilation is a combination of a number of elements like turn-taking, having engagement with the content, which in turn can be broken down further into elements of speech prosody, facial expressions, gestures, and so forth. And now we have really a chain of evidence, a bridge really connecting the low-level data at the bottom and the high-level inference models. That, in a nutshell, are two of the major pieces of innovation that the team's been bringing to bear in solving the problem, which is how do we measure collaborative problem solving? We've taken the tack that instead of building a traditional test for it, or even a questionnaire, and there are some examples of that out there, we wanted to tap into the power of online multiplayer video games. Like kids and even adults love to play games. And if you ever played World of Warcraft or Fortnite, you know that they can really be engaging as far as the participants are concerned to elicit cooperative play and collaboration. And we feel that's a great vehicle to be able to not only elicit that kind of behavior, but also make it ecologically valid. That it's actually something as, well, perhaps it's not going to be necessarily the exact rendition of the kinds of collaborations that might take place in the wild, perhaps in the workforce or what have you, but it's a pretty close sort of connection to it. The game, particularly the game genre that we've chosen, is called the jigsaw puzzle games. All right, so the idea is that two or more people can get together in solving a problem-solving task. Each player or each participant has a different part of the puzzle that they want to bring together to solve the whole game. And so by design, there is a cooperative or a collaborative element to what the game is.
Saad will give a demo of the game at the 2019 Education Technology and Computational Psychometrics Symposium, or ETCPS 19. Now we have some of Dave Edwards' presentation on CPSx at the ACT campus in Iowa City. Dave is a video gamer, and you can really hear his love of gaming here. He discusses what collaborative problem solving is and where this project will go next.
So the game itself is a two-player cooperative game. You can actually play with more than two if you want, but the way we've designed it is 2 players. And it's built by this company, Glass Lab. The game itself is basically you have a puzzle that you try to solve, and one person has access to the puzzle, and then there's a bunch of instructions about how you might go about solving the puzzle, and the other person has access to those instructions. And so there's really a lot of places where the people have to work together to share information and navigate through the instructions in order to get to the end. So this game is also modeled off a commercial game, which is called Keep Talking, Nobody Explodes. I don't know if you've ever played this game, but the idea of that game is you're trying to defuse a bomb. The premise of that game is exactly the end of the movie Speed, which I know is kind of a dated reference at this point, but Keanu Reeves climbs down underneath the bus to try to defuse the bomb. He's just a regular guy, but he's on the phone with the bomb squad who tells him to cut the green wire or something, and then he does that, and then they win. Well, they don't die, at least, which is good. So the game itself is structured in this way. There's basically, the game is divided up into kind of 6 segments, and each of the different segments has some different similarities and some differences that are kind of interesting. So the very first segment is kind of like getting into the game, matching with your partner, talking to your partner in the lobby before the game starts to kind of get the feeling of like, what's your name? Who are you? What are you gonna do? I guess it looks like I'm the astronaut this time. You'll be the engineer, all that kind of stuff. So there's some conversation that goes on about getting ready to start the game. So we're collecting specific kinds of information out of that segment, which is different from other segments. Then there are 5 mission segments where you actually like play the game. And so a mission is kind of a timed experience, which is in our case, between 4 and 8 minutes. And in that mission, you have a number of sub-tasks which you are trying to solve. So the sub-tasks come from a collection of 6, which you could consider these to be like tech-enhanced item types, if you will. And each of these different 6 tasks is kind of designed in a slightly different way, and we've been looking at the different types of evidence that we can collect from each one. The other thing which is interesting is in between each mission segment, there is an intermission segment where the players can talk with each other about what went well, what didn't go well, what they learned that time. Oh, I found there was a button at this part in the screen which was really useful. So you might want to use that button on the next mission. So there's definitely some conversation about what goes on, what happened. And so we're also collecting different kinds of information in that intermission period from the actual task period. And so there's a lot of different portions of the game where we're finding different kinds of things. The missions are here alternating in colors because the way that we've designed right now, the players switch roles in between missions. So I don't know if you've ever had this thing where you call up the help desk and you say, hey, I'm trying to do something, and say, why don't you share your screen, right? So the whole idea here is I don't know what you're seeing, and so it's a lot harder for me to work with you on what it is that you're supposed to do. Well, we've actually done that on purpose so that you can't see what your partner sees, but you do actually have an opportunity to take on their role for a certain period of time. So you kind of understand what it is they're supposed to do when they're playing that role. And so they go back and forth. And so they learn over time what each person is supposed to do, so they learn how to take on each role. Now, one thing which is kind of important about this is that this game is kind of novel to every player. And so what's kind of interesting about that is that both students and also adults kind of have a very similar kind of learning experience, and because you kind of start from scratch. And so we think that this fact will allow it to potentially be scalable across age groups. This is an example of the two interfaces that the two players see, and I apologize for those in the room. It's kind of small, but if you want to come see, or it's not small, it's just dark. But basically what's going on is on this screen, this is the person who's the operator. They're also kind of an astronaut. So they're on the International Space Station, and they have different issues which are popping up. They have alerts where maybe they're receiving a signal or there's an incoming asteroid. And so those are the individual like tech-enhanced items or the tasks that they have to solve. And then this is the engineer's interface, which is pretty much a book. And so we can, and since we're tracking people's eyes, which I'll mention in a bit, we can actually see when people are reading different sections of the book, and we can understand at what point they would otherwise know, or we think that they should know, what the thing is that they're supposed to do next. So because these two different people have very different interfaces, they participate in really very different ways. Here's one example of how one task is worked so you can kind of understand. And for those of you who are interns, you will be subjected to this game. So this is not really cheating, but it's, you'll get a little bit of a leg up. So the operator sees this task over here. It's a circuit board with a number of wires. I'm not sure if the audience can see these wires at all. But so the first step is they have to identify that they're in the wires task. They have to let their partner know that they're in the wires task, and they have to navigate to the section of the booklet regarding wires. The first piece of information that usually is discussed is how many wires there are, what colors there are. Based on the instructions here, it's structured in different paragraphs based on the number of wires. So early on, students don't know that the number of wires is the most important first piece of information to get, but later on they do. And so we can actually watch how long it takes for them to learn that that is the first piece of information to share. And also there are other cases where even if they don't, the engineer can compensate for that fact. So what we're doing is we're looking at a lot of different elements of their conversation around this information exchange. You can kind of think of it as if I have a deck of cards and you have a deck of cards and you're asking me to give you some. And so we're kind of modeling this card passing as some of the thing. What is collaborative problem solving? That's a really big question, and that's one big problem in the industry really is that there's a lot of different frameworks for what collaborative problem solving might be. So one of the frameworks that we've kind of settled on through Alejandro's research is that basically collaborative problem solving kind of has four key components. It has to be a novel process. Otherwise, it's not really problem solving. It's just kind of working together. The solution has to be something which is visible to the team members. So it's not really like learning because you have to have an outcome which you can see, like we won or we lost. And if you don't have a visible solution, it's more of a learning activity as opposed to like a problem solving activity. So you can't find a solution, you're not really solving a problem. The roles have to be differentiated, which means that people have to be doing different things. Otherwise, it's kind of just parallel work. So for example, like the performance scoring team, each one of you guys reads an essay independently. So that's not differentiation of roles at that moment. You're working in parallel, but it's when you come back together and fuse the scores together. Now you have a different role. You have the table leader who's got a different role. So in that sense, it is collaborative. And it also has to involve an interdependency between the two players. So sort of an asymmetric situation, which clearly, as I've just described, we have here. The problem solving itself also breaks down into two major components, which are cognitive and socio-emotional. So the cognitive is kind of like, reading through the instructions, making sure you recognize what's going on. But then socio-emotional is kind of monitoring your partner's state, like making sure that they're following along with you, making sure that they're engaged, that they understand what you're talking about, all those kinds of things. And so we're trying to address both of these simultaneously in our measurement. So what we're doing is we're trying to collect information from watching them play the game. So this is what our information collection setup looks like. This is our data collection setup. So we have a laptop, we have an eye tracker bar here, courtesy of ACT Research Department, thank you. We have a webcam, so we're recording their face, and then we're using some other software to record their screen, some of their mouse movements, and then also they're having an audio conference over Skype. So we're recording that conversation, and then we can take all of that and go through a series of processing through a lot of things Saad was talking about, computer vision models, natural language processing models, automatic speech recognition models, these kinds of things, in order to get this kind of very low-level data in order to help us make this hierarchical inference as was described. So we have something called Noldus Face Reader. This is out-of-the-box commercial software. What it does is you feed in a profile video, and then it analyzes that video for a number of different kinds of things. So what's going on down here is it's like locating different portions of the face, whether or not they're blinking their eyes, or whether or not their cheekbones are moving, which we can sort of infer are things like smiles or frowns. things of that nature. We're transcribing their audio. So we take their audio, their conversation, and we push it up through an Amazon automatic speech recognition. So here's an example of what they're saying. And then the idea here is that we're going to be extracting certain features of their conversation, which are indicating particular actions that they're taking. Am I sharing information with you? Am I acknowledging information that you just shared with me? Am I asking you a clarifying question? Am I just making an aizuchi, which is an interjection, like just saying the word okay, which is kind of an active listening kind of behavior. So we're going to be, and there's a slide a little bit later, but we're going to be building natural language processing models to extract these kinds of features out of their transcripts. Some of the features that we're looking for is like how many times does a person use you versus I? Are they more myopic or more looking at them? Are they asking clarifying questions? Some of their conversation is actually just reading the booklet out loud so that they have a shared understanding of what the rule is. So I find those very interesting. And the people who do versus don't read it out loud is interesting. There's also something else we're doing with the eye tracking data. So with the eye tracking, there's something called areas of interest. And so what you do is you define certain regions on the screen which are of interest, and you kind of annotate them as being something. So in this particular frame, there's a user camera in the top left. This is basically a picture of myself. Over here is my collaborator, who I may or may not be looking at any given point in time. But when you look at the heat maps for these plots, there's a lot of density around their collaborator video. What's interesting there is kind of differential behavior based on the video conferencing. And then there's obviously a giant frame in the center of the screen, which is the game. And then inside of the game frame, there are a lot of subframes, like here's a paragraph, here's a button, here's a wire, all of that kind of stuff. So what we can do is we can annotate their points, and so we know where they're looking at what points in time, and so we can look at certain sequences, like they saw the wire, then they said the wire, then their partner looked at the wire. So we're really looking at these complex processes of the collaboration. What we're doing is we are reviewing all of the video by hand right now in order to develop a training set for this kind of evidence that we're looking for. So we have right now a couple of research assistants, some of them in the room right now, thank you very much, who are watching all of this video, and they're annotating along all of these different dimensions of what is going on at that point in the video. So are they having a speech? Are they making a gesture? Those different kinds of things. Here you can see this person is laughing at this point in time, or they're smiling for this period of time. So the idea here is that we're annotating what's going on at different points in the video in order to create a training set so that then we can train a predictive model to annotate these videos automatically for us. So that is what we have kind of here. This is the idea of the predictive model. So these are all of these different kinds of tags that we're looking for. And you can see that we're looking for these tags at different portions in the game. So we might be looking at them during the keypad task or during the circuit task. There are slightly different kinds of evidence that we're looking for. Samples, utterances that they might make, or other kinds of modality that we're looking at for the data, as Saad was mentioning. So it might be an utterance or a gesture, or it might be an eye gaze data that we're looking for in order to predict this tag. So this is what we're calling the predictive model, where we can sort of let the machine watch the video and tell us what happens inside of it. This is really important for scalability, basically, if we want to develop sort of this kind of experience for a lot of people. Then what we have is we get all those tags down here at the bottom, so this is what we call our evidence, and then we infer, using this hierarchical model that Saad described earlier, we infer our way up towards the top, towards collaborative problem solving. So one example here is to suggest a course of action. So suggesting a course of action is related to decision making and execution. I'm not sure where the arrow is up here. But anyway, the point is that there's that, which is related to them saying something like state a wire to be cut. So this is a way of suggesting a course of action. We can then infer up towards their decision making and execution. Okay, so we just finished our second pilot study. We did a first pilot study last summer with the other ACT interns. And this is some information about the data that we're collecting for them. So not only are we having them play the game, but we're also having them to respond to surveys that we understand a lot more about what's going on with the survey. Because there's been tons of psychometric research, obviously, on the surveys up till now. So we have just some high-level demographics survey data where we're asking things like their gender, how much they play games in the past, those kinds of things, different sorts of stuff we think might be related to how people play games differently from one another. Because obviously not everybody plays games the same way, and so we want to be able to kind of control for that as much as we can understand how. We had them take a specific collaborative problem-solving survey, which is designed by our Learning Solutions Director, Yigal Rosen, which is kind of a self-report survey of collaborative problem-solving skills. Through also collaboration with research, we were able to have them take the Tessera assessment, which was really, really nice. The Tessera, it reports socio-emotional on 5 scales, which we'll talk about in a minute. And so these are both going to be a validity measure for us for some of the inferences, but also potentially we may be able to learn other properties in order to predict certain behaviors that people might do based on like, well, they have a high leadership score, so it's more likely they'll take the lead. Or maybe vice versa, we saw them take the lead and that correlates with their high Tessera score, right? So there's a couple different ways we can use the Tessera data, so we're very excited about that. And then a self-reported survey after they played the game, like did you have fun? Did you know your partner? Do you think your partner did well? You know, because sometimes when you work in groups, I don't know how much experience you guys have, but you're like, oh, you know, my partner didn't really do their job. So we put that question in there just so we can kind of control for that. And then as they play the game, we're collecting all this other data, as I mentioned a little bit before. So we've got their audio transcripts, we've got video of them, we have all this telemetry out of the game log, which we were able to develop in concert with the game developers. And then we also have all of this eye tracking data and areas of interest that we're annotating. So like I just said, we just finished a pilot study in local schools, which is really, really fun. It was a humongous amount of work, but it was also super cool. So we went there and they were willing to partner with us. They got a couple kids out of class at a couple points of time. They came, they played our game and participated in our research. And I got a lot of positive feedback from the kids. They really enjoyed it. Some of them thought it should be harder. So I was excited to see that. So looking forward, what will this become? Like, what would it be? So what's really interesting, I think, about this is because it's kind of, we think of it a little bit like a formative learning experience, really. And so we wanted to be able to start envisioning how we would provide feedback to people who participated or who took this or something. We've already written like 3 papers, I want to say, given at least 2 presentations at the conference. I'm flying out next week to go give one with our partner in the UK. So like we're definitely already starting to produce some research out of these data.
Well, thanks for listening. Thank you, Dave and Saad, and thank you, KCRG TV. They gave permission to play a clip from their CPSx news segment, which aired in May 2019. Thank you to Iowa City and Cedar Rapids schools, students, teachers, and administrators for helping with the CPSx study. And thank you, ACT audio-visual expert Eric Dickerson. He recorded Saad and Dave's Power Hour presentation at ACT.